Hey, Algebra 1. Today we have talked about several different things. We've learned how to look at a polynomial and classify it by degree. Degree means the exponent or the power of the variable. So for example, linear is when the variable has a power of 1, or cubic is when the highest power is a 3. We also talked about how to look at a polynomial and know how many terms there are. So this one has 1, 2, 3 terms, hence the word trinomial to describe 3 terms. Or maybe it is a monomial, it only has 1 term. Or maybe it's a binomial, it has 2 terms. So that's definitely something we want to practice. Knowing those vocabulary words will be helpful in the future. The next thing we talked about was greatest common factoring, GCF. And basically our goal is to move backwards into what distribution would have looked like. For example, real simple pattern, 2x plus 6. If I was thinking what did I distribute in the beginning, I must have distributed 2. And I must have multiplied 2 times x and 2 times 3. And so that is a basic idea of what greatest common factor looks like. And so today we did several problems that look like that. Some of the more challenging ones have to do with variables. So for example, 18x to the 7th minus 60 x to the 3rd minus 30x squared. If I'm looking at this, I want to address this in 2 different ways. First of all, what does 18, negative 60, and negative 30 all have in common? Well, all of these numbers are divisible by 6. And if I use division, 18 divides by 6 to give me the 3 here. And negative 60 divided by 6, that gives me the negative 10 in the middle. And negative 30 divided by 6 gives me the negative 5 in the end. So that's the first thing we look at. The second thing we look at is the fact that all of these terms have a variable. And I'm looking for what they have in common. So if I have x to the 7th, 1, 2, 3, 4, 5, 6, 7, they're all multiplying against each other. And then x to the 3rd, 3x is there. And then x squared, 2x is there. And so when I'm looking for what they have in common, I really want to lock in on the smaller amount, because if they all have x's, then they'll all have whatever the smaller amount is. So that's what I'm choosing. I'm choosing to take out x squared. And it's like subtraction really. 7 minus 2 leaves 5, and that's the 5 left over. Or 3 minus 2 is 1, and that's the 1 that we had left over. And then that last position, well, it doesn't have a variable on it at all. And so when I distribute 6x squared to each of those terms in parentheses, I will get exactly what I started with. So I want you to try number 24. You should have a number out front, and then you should have 3 numbers in parentheses. And they should either have a plus or minus separating them. Give it a shot, we'll look at it in class. The next part I gave you was just some practice of some basic concepts of slope, whether it's in graph form or slope form. So if I'm looking at the graph form, I really think of slope or average rate of change as rise over run. And so if I'm counting how much it went up, how much it went over, it seems like it goes up 2. And it runs 1, 2, 3, 4, 5. So essentially, this slope is positive 2/5. So you try number 26, see how well you do, and we'll look at that tomorrow. The next thing is just simply using the slope formula to calculate the rate of change between 2 given points. And so the first one, it looks like you have y2 minus y1. That would be 13 minus 13. And I'm actually going from the right to the left, and that is important to distinguish, because if I go right minus left the first time, it's important I go right minus left the second time as well. So go ahead and simplify that and tell me what you get, and then you can try number 28 independently, and we'll check your work. So a little bit harder is finding the value that would make a certain slope. So for example, I get 2 points. However, one of the x values is unknown. but I actually know the answer. I actually know a slope value that I get out. So instead of just plugging things into the formula, so I have, for example, we did 1 minus 4 divided by x minus 1. But I know that that should come out to equal 3 over 4. So your goal is to basically get out of this equation. So I may start by simplifying a little bit. On the right side, I see 1 minus 4 in the numerator, and that makes negative 3. And so now I need to figure out how to solve this proportion. So I'm going to start with cross multiplication. 4 times negative 3 is negative 12. And if I cross multiply the other direction, it's important to understand that distribution is a part of the process. 3 times x, 3x. 3 times negative 1 is negative 3. And now your goal is to tell me the value of x by solving that equation. So I set up number 30 for you in a similar way. I set up the formula subtracting the y's and subtracting the x's. And I went ahead and set it equal to the outcome that it says I should get. So your target is this y value. What would that number be to make the slope exactly negative 1? Find the slope of each line, and it's in equation form. I talked about how this new textbook doesn't use mx plus b. It uses ax plus b, but that is the exact same thing as mx plus b. A represents your slope or your rate of change, and that's because that number gets to multiply against your input value. So it has a lot to do with the pattern. And so for number 31, real simple, my slope is 1/5. But in number 32, this is what we call standard form, where basically all of the variables are on the same side and they come out to equal some type of integer. So I've begun to solve for y by subtracting 3x to the other side. And now if I really want y by itself, I want to divide by negative 4. So I want you to tell me what would that be, and then the question really wants the slope. So what would you say the slope is of that equation? Lastly is just getting us some practice with graphing, but slipping in that standard form concept. And so what I did for number 33 is I subtracted x from the left side to the right side, and then I divided that negative 1 coefficient over to the other side. So that ends up giving me positive x minus 1. And now if I want to start thinking about graphing, I could just consider making a table, pretending I could plug in some values to get out some values and plot some different points. So what if I plugged in 0? 0 minus 1 would make negative 1, and that is this point right here on the y-axis. If I was to plug in 1, 1 minus 1 would be 0. 1, 0 is right here. If I was to do 2 minus 1, you would get 1. So 2, 1 is a point. And now we see that that's going to trend in the positive direction. And if I was to go backward and say, well, what's negative 1 minus 1? Well, that'd be negative 2. And negative 1, negative 2 is your next point. So one day, students start moving a lot quicker because they understand the idea of slope, intercept, form. So the idea of the y-intercept is really telling me what that first point is. And then that slope value, whether you think of it as m or a or whatever number you want, that in this problem is a 1. So that means I should see a rise run of positive 1. And that's what we're seeing. It's going up 1, right 1, up 1, right 1. So I want you to try the next one. Try to see if you can solve for y. You need to get y by itself in order to do that correctly. So I'm going to start by subtracting that 4x over, and that's what I've got over here. And I will check your work tomorrow to see how closely your graph aligns, but we'll also check your equation. So if you have any questions, please ask tomorrow. Give it your best effort, and I'll see you tomorrow.